Good evening. Hello.
Hello, good evening, sir.
Good evening. So, so should we start now? All the speakers are there.
Yes, sir, we are available.
All are available. Okay, then I can start the webinar and go live, and then we can start the webinar.
Uh,
I'll give the introduction, and then we can go live. Huh?
Sir, can we wait for another couple of minutes?
Yeah,
Maybe.
no problem.
Yeah.
It's now
Okay, okay.
3:56, so we can wait.
Yeah, yeah. Sir, we can start now.
Hello.
Hello.
Uh, yes, please tell me.
Yeah, sir, we can start now.
Okay. So, okay, then we are starting. Uh, I request all to switch on the video because we will be going public. So let them have a view of all of us. Good afternoon to all. Myself, Puneet Chakrabarti, Deputy Director Technical of the Institution of Engineers India. I welcome you all to today's webinar on a very interesting topic, spring hanger selection and sizing scissor tool and best practices and optimization techniques. I welcome our esteemed speaker today, Mr. Srinivasan Kapati. He is the business head of ImageGrafix, and with him is Mr. Vishwarup Chatterjee. He is the regional manager of ImageGrafix. And also we have with us Kaustubh Roy Choudhury. He is the Assistant Manager, Pre-Sale of ImageGrafix. And we are glad to have Mr. Vishwarup Chatterjee also as the moderator who will be conducting this program. I welcome all the participants. I hope all the participants have already joined here. And now I will be handing over to conduct this program to Mr. Vishwarup Chatterjee. Mr. Chatterjee, please. Mr. Chatterjee is there. Vishwarup Chatterjee is the regional manager with years of experience in delivering advanced engineering design solutions. As regional sales manager at ImageGrafix, he leads the implementation and training of cutting-edge solutions across the engineering, infrastructure, and manufacturing sectors. And Mr. Chatterjee has empowered numerous teams in India to streamline workflow, adopt 3D modeling, and transition smoothly to latest technology. He is recognized for blending technical precision with practical insight, making him a trusted advisor to engineering firms. I request Mr. Vishwarup Chatterjee to come online.
I think he has
Is he
an
not
issue.
available?
I think he was still he was there till there till this moment.
Yes, some technical glitch. He's just joining in.
Okay, then I request Mr. Srinivas
Yeah,
Tapati
yeah.
to start your presentation.
Yes, yes. Thanks for the
I'll
opportunity.
give a brief, I'll give a brief detail about Srinivas Tapati. He is a senior sales leader with over 2 decades of experience in driving digital transformation across the engineering and infrastructure sectors. As sales head at ImageGrafix, he spearheaded strategic partnership and solution delivery for global recognized platform across India. With a deep understanding of multifunctional ecosystem, Mr. Srinivasan has worked closely with EPCs, government organizations, and industrial clients to deliver scalable, future-ready engineering solutions. He is widely respected for his consultative approach and his ability to align technology with business outcomes. Now I request Mr. Srinivas Tapat to please go to the presentation.
Thank you, sir. It's been great privilege for us as a part of ImageGrafix team to probably to host this instance to be a technical seminar for the IEI. And so, because we always have a great instance respect towards the institution of engineers, because where we start our nurturing steps as an engineer, because even as a professional, when probably started my career as an BTech, because we always looked up to IEI, and probably being part of this journey, and probably on this day probably representing my organization to present a technical seminar from my team, and this is really an honor for us. And thanks for this opportunity given to us. This would really I think I would probably request for more and more on this kind of seminars with coordination with IEI, and we would probably take part in probably making everyone understand the technical know-hows of what's happening up in the market. And probably since we have been dealing with the OEMs for quite some time, and so that's where I think probably we can probably more get connected to the the core team, where we call as. So that's really a great opportunity for us. So yes, briefly, thanks. Probably I think you already briefed my profile. I had been with this organization for around 15 years now. It's the 16th year for me. And yes, I started my career as a sales manager, and probably yes, I'm heading the team right now. And just wanted to probably brief you about my company. And so this we are so, we are ImageGrafix, and yes, we are this leading system integrator, and we have been probably supporting the all the life cycle of industrial facilities. So we are not able to see you.
Just a minute, sir. Let me reshare. Yeah.
Yeah, we have been partnering. We have the partnerships of the technical for the technology for with the greatest of the technology providers. We have the customer base, almost all of the oil and gas consultants in India and also in the Middle East market. Recently, I think for 2025, I think 2024, 2025, I think we have been adjudged as the best partner for the hexagon business in the world. Basically, we started our operations in Dubai, which is probably around 20, 26, 25 years back. And we have expanded our horizons towards Saudi Arabia and also Abu Dhabi and Qatar. In India, we have started our operations around 17 years before, 18 years before, in 2006, as I remember. I think we have registered our office in 2006. So it's been around 17, 18 years in India where we have been working with you all, as I said, because we. We have offices all over Dubai. We are in Jebel Ali, and in offices we have around in India we have around 9 offices, nine centers, which stand. Our head office is based out of Chennai, and expanded our origins towards Bangalore, Mumbai, and every metropolitan. And we are also based out of Pune and Hyderabad. Actually speaking, yes, since our inception has started in Dubai, which we call Dubai-based organization as of today. So which is around 27 years of experience. If you probably take every branch into the consideration and probably every country where we are exactly into the 15 locations. All over, I think we have around 200 plus. I feel it is more than right now. I think 250, 200 plus of employees. When it probably take the color customers, I think 1500 delighted customers. You see, delighted customers. I think you only see in the attendees. I think there are many of the people who are already taking care of or taking our services in it. I think you should be. I know that you might be delighted, so I can say that as a delighted clients. Actually, see, the basic vision of ImageGrafix has always been to be most reliable and trustable global business partner. We also known as the greatest of the leadership capabilities because we have been driven by our really a great team, management team.
Mr. Kaparti.
Yes, sir. Please.
Sorry to interrupt. Can we come to the topic? Today's topic on the. Can we come there?
Yeah. I think then. I thought I'll probably brief you on my company profile, and then probably it will be taken over by. So okay, then I'll just probably complete my vision and probably the clients what we are actually focusing on. So
I think that these participants are eagerly waiting for the topic.
Yeah, sure, definitely.
Topic.
Yeah. I will. I think I will hand over a quick to my technical team. Yeah, I think probably it's a self-explanatory vision and mission. So I just don't want to probably waste off my time, your time in this. So can we just move on to our clientele list, Kaustav? This is, so can you just go to the board of directors? Board of directors. Our board of directors are actually our CEO is Mr. Amir Hesmati. He is based out of Dubai, and Venkat Raman. He is the director and the shareholder. He also is based out of Dubai operations, and Shaju Joseph, he takes care of the CAD/CAM CA team, and Sitaraman Parthasarthi is based out of Chennai, and he's our operations director, where we all report to him. So we also have a management committee who are part of our core team. Mr. Yuvraj and Pandyan adds to that list. Yuvraj is energy solutions head, where he takes care of all the Middle East and take care of an Indian operations also. So Pandyan, who is looking after for the engineering services and also an enterprise solutions department. So just wanted to probably brief you on our clientele list. So can you just go in? So these are the partners I think we represent. I think can you just go with the partners? Yeah, our partners. These are our technology partners. We are basically focused on Hexagon and partners with Oracle and PTC. And we also have the other partners like Brixis, SEG, and Senesco. AFT has been one of our premium technology partner where we have been doing the services for them. And Hexagon has always been our flagship OEM where we have been running for them. For it's been around 15th year for us right now. And these are our customers. You can probably these are of self-explanatory, and probably I don't want to probably speak on our clientele list. So every great giant is our customer, and which from Tata to BHL to Jacobs and Linde and all. So I just probably end my brief cut short presentation here. So I can probably transfer it to my team, who is an assistant sales manager for pre-sales. He can take over for the day's topic. Thank you. Thanks for this opportunity.
Thank you, Srinivas sir, for the introduction, and thank you, the Institute of Engineers team, for collaborating this session. So this is our first session with Institute of Engineers, where we are actually presenting some technical topics, basically. So we'll start with the hangar design, as Sudip sir said already in the beginning of the session. So let me share my PPT. My screen is visible. If anyone, please confirm.
Yeah, it's visible.
Okay, great. So myself, Kaustav, I'm working as an assistant manager pre-sales with ImageGrafix. And as I said, this is our first session with Institute of Engineers, where we'll be representing a topic regarding the spring hanger selection and sizing in Caesar 2, and how we can, what we say, adopt the best practice actually to optimize these things using the Caesar 2 software. So this is the agenda today of our session. So first of all, we will look into this, that how the spring hanger works actually. So most of us are aware of it, okay, who are basically from the piping department. So why we use spring hanger, so that we will look into first. Then the selection of the spring hanger, that is very much important, because what type of spring hanger we will use, or in which condition, okay, the particular type of spring hanger will be suitable. So all these things we will see into this session. Then next to that, the mathematical calculation behind it, and also we will verify our manual calculation with the Caesar 2 report, okay, so that we can very well, what we say, come to the conclusion that the procedure what we are following in Caesar 2, that is correct, and we can select the exact size and the capability as per the figure of different hanger vendors, okay, and we can select the spring hanger accordingly. Then we will see the load cases, because Caesar 2 is a pipe stress analysis software from Hexagon. So any analysis software, we know that we have to build some load cases basically to derive the calculation. So in Caesar 2 also, we have certain load cases that can actually use to design the spring hanger. So that also we will see that which are the load cases that are associated while designing the spring hanger. Then we will see that what are the design methods that are available for selecting the spring hanger and the settings in the teaser 2. There are different settings. If you when we are into the live session, we will see that in that interface there are different settings available. So which type of settings will be appropriate for us and when to use that particular setting? So that also we will look into this session. So coming to the first part, that how spring hanger works, right? So the basic of spring hanger is nothing but, so as the name implies, the spring hanger is nothing but there must be a spring coil actually. So it must be sometimes in tension and sometimes it will be in the compression. Okay. But when we use the spring hanger, that is the question. Now we use the spring hanger basically to take the piping load. Okay. And the another aspect is to allow the movement of the piping system, right? So we'll be working in the different operating condition, and there must be some movement in the piping system that must, what we say, that will be the use of spring hanger, so that that movement can be accommodated by the spring accordingly. So there are two mechanisms basically. So one is to carry the load, and the second is basically to allow the movement of the piping system, right? But there are some misconception also that spring hanger may be used due to the to arrest the thermal expansion, but that is not right at all, because we do not use spring hanger to arrest the thermal movement, because in those cases we have other components like the bellow. Okay, so that we use basically to arrest the thermal movement. Okay, but spring hanger is basically used, as I mentioned, for these two cases. Now we have different types of spring hanger that is also available. So one is the constant spring hanger and another one is the variable spring hanger. So variable spring hanger means the force will vary, okay, due to its vertical movement. Okay, so the force will not be constant during its movement of the spring. And the second thing is this constant spring hanger. So constant spring hanger is nothing but where you can say the force is nearly constant throughout the movement of the spring, right? But there are certain criteria basically when we'll be using the variable spring hanger and when we'll be using the constant spring hanger, because we know that constant spring hanger comes with a higher price, but definitely as per the safety is concerned, we in specific cases we do have to consider, or there are some boundary condition. If it is beyond that boundary condition, then we must have to use the constant spring hanger. Else we can very well go with the variable spring hanger. Okay. Now the next thing is the spring hanger selection. So what is the basic methodology for that? Okay. And how we can approach by selecting the spring hanger if we go for a manual process. Okay. So in that, let's say I'm not using any kind of software. I'm going with a manual approach to selecting a spring hanger, and we will see that how we can actually achieve a particular spring hanger. Okay, that can perfectly fit for a particular condition that we will discuss in a specific example. So first of all, we need to determine what is the hot load required and the pipe movement. So hot load is nothing but the operating load that my spring hanger must carry, okay, when the pipe is in the operating condition, and the amount of movement also when the pipe is in operating condition, that should also be accommodated by the spring hanger. So these two cases, as I said, must be what we say match when we are selecting the spring hanger. Then we need to estimate the travel range from the catalog. So from which catalog? So there are several what we say the vendor catalog are available in the software. Okay, so different international vendors are there, Indian vendors are there. Okay, so based on that, so almost we have 25, 26 vendors are available. Okay, vendor catalog is available in the software, so we can select one of the vendor, and based on that vendor catalog, it will select the spring hanger for us. Okay. Like for Indian vendors, you can say we have the BHCL, we have the Sarathi, we have Techno Industry. So these are the Indian vendors which are available in the Web2. Okay. Then we have to, in the third step, we have to go to the smaller size for the vendor catalog, which has hot load within the travel limit. So for each size, we have some what we say load limit or load range basically. Okay, so this is a load range. Let's say from 1,000 Newton to 2,000 Newton. So if my load is within that particular limit, so I can select that spring hanger. And for that spring hanger, there must be some specific spring rate will be there, and the figure description will also be there. So based on your evaluation, okay, then only you can place a order to this hanger vendor that this hanger will be required for my purpose. Okay. Then in the next step, okay, we have to calculate the core load. Okay, so in the deadweight condition, what is the amount of load that my spring hanger must support? Okay, so there are two conditions. So in the operating condition, my pipe may lift up or it may go down in the downward direction. Right? So if it is going in the upward direction, then the core load will be calculated in such a way that it is the operating load, means your hot load, plus the movement of this piping system multiplied by the spring rate. Okay, so this is the first formula what we'll be using if the piping system is going in the upward direction. Then the next thing is if it is going in the downward direction, so definitely the core load will be the operating load minus your movement multiplied by the spring rate, because as the direction is different and as this is a vector quantity, so definitely my sign convention will be just different to that, right? And also in the next step, we need to ensure that the calculated core load, okay, that must fall within the range of the spring size selected. Let's say I have selected a spring size of 4 inch. Okay. So in the particular catalog, so there must be what we say load range for that. Okay. So my hot load and cold load, whatever the range I'm working in that, so that must be within that limit of the hanger. It should not be beyond that. Then we have to go for the higher size. Okay. So our design should be like that. We have to optimize that. We should not go for under design or we should not go for over design as well. Okay, so that is the main purpose of this uh, particular topic or session. So how we can optimize and select the spring hanger, because if we go for the over design, definitely it will not be a cost effective solution for us, right? Now the next step is, once the spring size, hot load, cold load and the spring rate as well as the travel is calculated and finalized, we need to check the variability. So variability is nothing but what is the load variation between your hot load and the cold load. Because there are certain guidelines are there. If the load variation is very much on the higher side, okay, so in those cases, we have to go for the constant spring hanger. Okay, so usually we take the load variance as 25%, or in few industries, okay, if we are going for more stringent type of calculation, then we can take 15, 10%, 15% also for that. So if my load variation is more than that, let's say I'm taking the load variation, let's say 25%. So if my variation between the hot load and cold load, if it is more than 25%, then I will be definitely going for my constant spring hanger. Okay. So what are the formulas basically to calculate the variability? So these are the two formulas basically. Either you can go for the movement multiplied by spring rate divided by your hot load, and that should be multiplied by 100 to take it into the percentage variation. And the second thing is your hot load minus your cold load divided by hot load multiplied by 100. Okay. So this is the two formula which we'll be using to calculate the variability. Okay, but in Caesar to input, what we have to specify, that what will be the load range variation for that. Okay, so that it will be coming as a criteria for Caesar 2. Let's say if my variation is more than 25%, it will directly go for the constant spring angle. Okay. Now coming to the mathematics, we have the selecting the spring angle. Okay. So let's say in the initial condition or in the dead weight condition, okay, we have a load of 400 kg. Okay. So this is a simple example, because in Caesar 2 or in pipe stress analysis, we are evaluating the system as a beam theory, right? Okay. So in that, let's say each of the support here, what we can say, okay, or each of the human, okay, who are carrying that load, let's say taking 100 kg of load. Okay, so total load will be distributed in that fashion. But in my operating condition, let's say my pipe leaks off. Okay, and in such condition, definitely there is no support in this particular location. Any question? No. Okay, fine. So in this case, you can see that the what we say for this particular support, it has to take 150 kg of load, and the next to support to the right hand side. Okay, so it should carry the load of 125 kg each. So each of the support has to take more amount of load if one support is gone, because if my piping is lifting off, okay, so it should not be in contact with that particular support. So the entire load, okay, has to be compensated by the other support. Okay, so the nearest support which are available, that has to take the higher amount of load compared to the rest condition. Okay. Now we'll be taking this example where my pipe size is a simple example. I have also given the dimension here, means the length of the piping systems, and we have the pipe size of 8 inch. Then we are using the material as A106 grade B. We are using the schedule 40, temperature as 225 degrees centigrade, pressure as 500 kPa, and we are using corrosion also 0.5 mm. So this is our configuration for the system. And also we have the steel length given here. Okay. So now in this particular example, so it is connected from one equipment at the node number 10. Okay, basically a vessel. Okay, and it is connected to another equipment, let's say one of our exchanger. So in this process, basically, you can see that we have a support placed in this location. We have a rest support placed in this location, and this position is anchored because it is connected to the equipment nozzle. Now, I go to the software directly. My software screen is visible. If someone please confirm. Hello. Sudipta, hope my software screen is visible, right? Okay.
Yes,
So in this,
yes.
okay, thank you. Yeah. So in this case, basically, what we'll be doing, this is a piping system, let's say. It's a simple assembly kind of thing, we can say. And here, what we are doing basically, that is, this is the spool, okay? And we have then the vertical spool. We have a support here at the node number 40. And we also have a support at node number 20. These are all the race support. And then it is connected to another equipment in this, okay? Now, in this example, if I run this file, let's say, and we have this property, so it's as I said, it's a 8-inch pipe. Okay, we have the material A106 grade B. Okay, and we have this temperature and pressure which we are working here. Okay. Now, if we run this file, so we'll be getting this output report from CZ2. Okay. So in this output report, basically here you can see that in my sustained condition and in the operating condition. So these two cases we will consider. So in these two cases, basically, if I go for the resistance summary extended report, so here you can see in the node number 10, okay, this is the anchor, and we also have the load in the X, Y, and Z direction respectively, and also we have the moment and the displacement as well. But if you notice at the node number 40, okay, so in the node number 40, in the sustained condition, definitely it is taking some load. Okay, so it is 1050 Newton in the downward direction, right? But in the operating condition, it is not taking any load. Why? Because definitely it is not connected with the support then. Because if it is connected with the support, then definitely some amount of load will be coming to the support. And also here you can see in this particular case, in the case number 3, means operating case at node number 40, we have a vertical displacement of almost 9.5 mm. So at that particular condition, my pipe is lifting off around 9.5 mm. So that's why it is not in contact with my support. And that's why there is no load on the support as well. If we see this in a little more graphical way, okay, so let us open this graphical view option. Just a minute. So in this, okay, so if I go to the plot view option, 3D plot, okay, and in this, okay, if I change the view to this, and if I just go for the deflected shape option, so now here you can see that the amount of deflection actually, here you can see that the blue color is nothing but this is in my standard sustained condition, and the deflected one is in my operating condition. So in the operating condition, there is a displacement, and we already know what is the amount of displacement from the output report. So that is around 9.5 mm in the upward direction. So in this case, definitely my pipe is not in contact with the support, right? And if you notice another thing, that as the support is not present in the operating condition due to lift off, the other support has to take higher amount of load. What are the other supports? At the node number 20 or at the anchor point, we will see that it has to take higher amount of load because total dead weight will be constant, okay, and that should be present in the entire system, whether we are into the operating case or whether we are into the different condition, okay, so that will be present throughout the system, okay. Okay. Now in this, if I again go to the operating and sustain condition, and if I select the restraint summary extended report, so here we will notice that at node number 20, in the sustain condition, it was taking something around 3256 Newton of load. But see what is the huge amount of load that is coming in the operating condition, as that support was not present in the operating condition, right? Similarly, if you notice at the node number 100 and node number 10, which are basically the anchor point in the operating condition, they also has to take higher amount of load, right? So that is also not a desirable condition. So in this case, okay, if I go back to my model, and here in this particular condition, if I remove the restraint from this node number 40, and instead of that, if I put a hanger here at node number 40, and let's say I am taking here as anvil, okay, as a vendor, hanger vendor, but as I mentioned that we have uh, almost 39 vendors that are available in Caesar 2, okay, and also we have the Indian vendors that are also available, like, and each individual vendors, okay, respect to the which country, that is also available just beside to that, like Sarathi is from India, okay, BHEL is from India, okay, and also we have the techno industry from India, okay, so all these Indian vendors are also available in this list, okay, so this is the techno industry. Here you can see at number 33. So you can use your desired hanger vendor for that. So in this case I'm using anvil, okay, and I'm using the load variation, as we were discussing earlier, that the load variation, if it is more than 25%, then my software Caesar 2 will go for the constant spring hanger instead of variable spring hanger. So I can allow the load variation between my hot load and cold load up to 25%. Okay. And also I have checked this box, allow short range spring. Okay. So that is nothing but your, if the what we say load requirement is very less, so instead of hanger support, it will go for a spring support in that particular location. Okay, so that will also see, these are the different settings that we'll also see in another couple of slides after this. Okay, that what are the different options available and when to use that particular option in the different design phase of spring hanger. And also we have the available space, means definitely if you are installing a hanger, so hanger must be hanged with any of the beam or any other support from the top or from the bottom. Okay, so in those cases, what is the available space for that? So that is from the hanger starting point to the center line of your piping system. What will be the length for that? So that you can provide. Okay, so here, if it is a means if it is the hanger is placed or the spring support is placed at the bottom of the piping support, okay, so then we have to specify the distance in the negative direction. That's a negative 200 mm. So this is the available space for that, so that Caesar 2 will evaluate that this amount of space is available, and for that also it will check what is the hot load and cold load, and based on that it will select the appropriate spring hanger for us. Okay. So now, as of now, I'm not giving anything. Okay. Let Caesar just take the full advantage and what we say, take the available space for that. Okay. And we will describe these other settings in the later part of the session. So now, once this is done, okay. So what we have to do, we have to go to our load cases basically. So in the load cases, first I have to start run because I have added the hanger, and then I have to go to the edit load cases option. So in the edit load cases option, basically, first I will go for the recommended load cases. Okay. Now, in the recommended load cases, here you will see the first two load case, L1 and L2. These are basically the hanger cases for me. Okay. So why two different load cases has been created? So as I said, that hanger should be used for two different purposes. One is to take the load of the piping system, and another is to accommodate the movement of the piping system. So the first load case will be designed that what amount of weight should be taken by the spring hanger, and the second load case that scissor 2 will create by its own, that how much the spring hanger has to travel, okay, when the pipe is in the operating condition. Okay. So these two load cases, we are not going to check any of the output parameters. This will be selected by scissor 2 by default to design our hanger. Okay. And that should be in, that is a automatic process. We do not have to, we just have to feed few data in that, as I said in the settings. Rest of the thing, scissor 2 will take care for you. Okay. Now, once this load cases has been done, you can click on the analyze option. So scissor 2 will now perform the analysis by having that particular spring support, and it will create a hanger table for us. So in that hanger table, if you remember, our sustain load was there as 1015 Newton, right? So in the hot load condition, my hanger has to take 1015 Newton of load. Okay. And what will be my install load? My install load is 1173 or 1173 Newton. Okay. So in that case means my spring will be in the pre-stressed condition, and whenever the pipe is moving in the upward direction, so in the hot condition, it should take the load whichever my normal rest support was taking in the sustained condition. And what is the vertical movement? Here is the vertical movement 9.595, which we have already seen in that output report. And this is the size of the spring hanger. This is 4-inch. So we are selecting as 4-inch spring. And we also have the figure number of 82 that must be there in the vendor catalog. Okay, the figure description. And this is the spring rate for me. This is 165 Newton per centimeter. Okay. So this is the amount of detail, okay, what we have in this. And based on that, and this is also the load variation, what scissor 2 will calculate. This is 16%. So that's why it is going for a variable spring hanger. Okay. Because I have given the restriction as 25%, because if it is more than 25%, so definitely it will go for the constant spring hanger. But as the load variation is less than that, it is going for a variable spring hanger for me instead of constant spring hanger. Fine. Now let me go back to the PPT once. Okay. So this is the representation what we have in the load case number, what we say the node number 40. So in the operating case, we don't have any load as the pipe is moving in the upward direction. That also we have seen in the graphical representation also in that in the 3D plot view. And this is the sustained load, which scissor 2 the what we say the rest support was taking in the normal sustained condition. Okay. Now we will see the mathematics. Now, if I have to solve this problem manually, I don't have any software, let's say right now. Okay. So I have to solve this problem manually, and I will see that whether this result is matching with my manual calculation or not. Okay. Now, my hot load or dead weight of the system is nothing but we know that it is 1015 Newton. Okay. And what is the delta or the movement? Movement is nothing but my 9.564 mm. Okay, so this is the amount of travel that my spring hanger should accommodate, okay, in the operating condition. Okay. Now we have two equations here. So in the first equation, my cold load is nothing but is equals to my hot load plus K delta. Because why I'm going for plus K delta? K is nothing but my spring constant. Delta is nothing but my movement. Okay. Because the pipe is moving in the upward direction. Okay. And I have given the condition that my variability should be less than equals to 25%. It should not be more than that. Else it will go for a constant spring angle. Okay. Then if that is the case, then from this we can derive the second equation that my cold load must be less than equals to 1.25 times of my hot load. Okay. So if I'm taking the maximum variability, let's say it is going for a 25% load variance. So in that case, my cold load, the maximum cold load will be 1269 Newton. Okay, with the 25% variability. So if I put this into this given formula, I can calculate my spring constant K. My cold load is there already 1269. That is the maximum one I am taking. Hot load I already know 1015 Newton. Delta I know that is 9.5 mm. So we can calculate the maximum K, that is coming around 26 Newton per millimeter. So my spring rate should be less than 26 Newton per millimeter. It should not be beyond that. So that is my K max, 26 Newton per millimeter. And my load range is nothing but 1015 Newton to 1269 Newton. Okay. Now, here, coming to the next thing, mostly the anvil, what we say, the vendor, what we have selected. So they mostly have the guide, what we say, the table or catalog, okay, in the Imperial unit file. So we'll be converting that into our unit file. So in that, my hot load is 1015 Newton. My cold load, maximum cold load will be 1269 Newton. Now this is my range. I know my range now, 1015 to 1269 Newton. And I have to select a spring that can accommodate that particular load into it. And that should come in the middle of this particular thing. Okay. So we have other method like extended method also that we will discuss once we are into these different settings option in the spring hanger part. But let us say we are taking now, it should be within somewhere in between that what we say that load range should come within in between that this particular load range for a particular size of spring. Now we can take the what we say K value, the same constant value from the table as 94. So if we convert the 94 pounds per inch to Newton per millimeter, so it is coming as 16.5, right? And yes, now my table value is less than 26, that is 16.5. So I can very well take that 4-inch spring, and this comes to the figure number 82. Okay. Now I know my actual K value. So simply what I can do, if I put it into the formula, I can calculate my cold load. So cold load is equals to hot load plus K delta. K is my spring constant. I know this value as 16.5 now. Delta I know that is 9.564, and hot load is 1015 Newton. So the cold load is coming as 1173 Newton. This is what we have calculated already in CZ. And the percentage variability is nothing but my cold load minus hot load divided by hot load. This is coming as 16%. Now, if I come back to my CZ2 report, the hanger report, now here you can see this is exactly matching to my manual calculation. This is my spring hanger size is 4 inch. Figure number is 82. My vertical movement is this much. This is fine. This is constant. We already know this. And this is my theoretical installed load, that is 1173 Newton. This is exactly what we have calculated manually. And this is the load variation 16%. Right? So this is how we can select a spring hanger, or we can design a spring hanger in CZ2, and this is the background method or the formula that has been used in the software. Fine. So let me go back to the PPT once. So this is the exact report which is matching with my manual calculation. And spring rate also here you can see it is 165, and what we have calculated, that is, this is in the Newton per centimeter, but ours in the Newton per millimeter, so it is 16.5 or 165 Newton per centimeter. So exactly matching with the manual calculation. Now these are the what we say the hanger design load cases, which we have discussed earlier, that first load case will be the amount of load that my hanger should carry, and the second thing is the maximum operating for my hanger travel. Okay, so the maximum movement that can be accommodated by my hanger, and the output status will be suppressed because we will be not taking any kind of output from this. This is just for the internal calculation for CZ2. Okay. Now we have somewhat middle of a particular size of the spring hanger, but we have other things like extended load range. So extended load range is nothing but the software includes the maximum load range to permit the selection or less expensive variable support hanger in place of constant spring hanger. So in any catalog at the bottom, you will see there are some load range that will be available in the spring hanger catalog. So that is because if my variability is very close to that, okay, and I can accommodate, or with the further calculation, I can go for the variable spring hanger instead of constant spring hanger. So I can do that. But that load should not be on a very higher one, because otherwise it should not comply with the safety. Okay. So that we can also use as per the extended load range spring. The cold load spring hanger is nothing but it is a design method that is designing the spring. In that case, the operating load or the hot load is supported in the cold position. So as we have calculated in this way, that my hot load is nothing but the amount of load that previously the rest support was taking. Okay, that I have taken it as my hot load for this spring, and the cold load I have calculated with the formula. This is the method which we have used. Okay. And also we have the hot load centered method. So in this method, what is happening? The hot load uh, should be closely as possible to the middle of the spring table. Okay, it will always try to go for the middle of the spring table. Okay, and and we have to basically adhere with that, but it is not always, because sometimes what happen, it is not exactly as the middle of the spring. Sometimes it should be shifted in the upward or downward load range. Okay, so in that case it will be managed accordingly. But the things what CZ2 will do, it will optimize the selection of the spring so that it should be efficient as per the cost, and also the what we say, the safety purpose will also intact in that particular selection of the spring. Now coming to the different settings that are associated with the spring hanger. So basically we have the node number. First we need to define that in particular which node number we have to connect this spring. Then in the second position is nothing but the hanger vendor we need to select. So as I mentioned that we have almost 39 vendors available there. Okay, so we have to select the hanger vendor, appropriate hanger vendor from the list. If you want to provide any tag number, so we do provide some support tag numbers, right? Okay, so for hanger supports also you can provide the tag number here. Then you can select the what we say the methodology that we have discussed in our last slide, that whether it should be in the extended range or cold range or the hot load centered method, which methodology you are using for this. Then the available space. So this is the clearance that is available for this. So if the spring support is at the bottom of your piping system, which we call it as a can, so in that case you can provide the negative distance in that. And also the load variation. Okay, so we have given 25%, but it varies from different industry. Like for the power industry we are more stringent into it, so you can go for less than that, maybe 20% of that. Or if for any other industry, if you want to be uh, further stringent to that, so you can take 15%. Okay, so but the purpose is nothing but if the variation of load is beyond that, it will go for the constant hanger spring. Then the displacement criteria for the rigid support. Okay, so definitely if it is coming as a what we say rigid support. Okay, so in that case basically it will not go for a spring hanger. Instead of that, it will go for a rigid support for that. Okay, then the maximum allowed travel limit. So this is also a criteria for me. So if I mention, let's say 15 mm. So if my load I mean my travel is more than 15 mm, then also it will go for a constant hanger spring. So by going with a constant hanger spring, there must be two criteria. One is the load variation, another one is the travel limit. So if anyone is the criteria is met, okay, with the given input, then definitely Caesar 2 will go for the constant hanger spring. Okay. Then number of hangars in the location. So that is again sometimes what happen if we have a higher pipe size. Okay, so definitely in a particular location, one hanger is not sufficient. We have to go for multiple hangars there. Okay, so to balance that particular load. So in that case, you can go for multiple hangars in the particular location. If you want to go for the short range spring, you can check this box. So it will what we say check the short range spring option, okay, as per the vendor catalog. Then the operating load. Sometimes what happens, you are reevaluating your hanger. Okay, you already have done, but now there is some change in the piping system, basically for your brownfield projects, and you are now reevaluating your hanger, that whether that hanger can accommodate that load or not, or whether I have to replace that particular hanger, because those are costly support. So we have to be very cautious about it. So we can evaluate it also. That kind of facility is also there in the software. So you can put the operating load directly into it. Okay. Then the hanger hardware weight. So hardware weight is also very important because the additional weight of the hardware. So that also you will be getting in the vendor catalog. So let's say for a particular hanger size or hanger selection, okay, you have that hardware weight. So you can put that hardware weight also here. So that additional load will be taken care by Caesar 2. Then multiple load case design options. So if you want to design it now I have designed it for the operating case, but there may be other cases as well. Okay, in the software. Okay, so if you want to design it for the multiple cases, so there all the load cases. So total 14 number of load cases will be there. So for that you can design the hanger. Okay, so whichever will be the worst, Caesar 2 will take it accordingly. Okay. Now, the free restraint at the node, the equipment nozzle load carried by the hanger. So sometimes what happens that whenever you are placing the hanger, my equipment nozzle is very close to that, and I don't want to give the extra amount of load to my equipment nozzle, because the safety of the nozzle is very much important here. And also what we say to qualify the nozzle also as per the piping load, so that is also very important. So in that case you can give a free restricted node. You can define the node number in that, And in the free code, you can define the basically in which direction the load is coming. So you can define that also in the y direction or xy direction. So that also you can define in this free code option. Then the predefined hanger data. So some predefined hanger data will be there now. If you have any existing hanger, that what we are discussing earlier, that for any existing hanger, you can define the spring rate, okay, or you can define for the constant hanger spring, okay, you can define that support load, okay. So what is the constant support load or constant effort support load, what we say, okay. So that also you can define it here. And also you can define either the spring rate or the cold load in case of a variable spring hanger. So these two things are for the variable one, and the last one, that is the constant effort support load, this is for the constant hanger spring. So whatever your constant effort support load, you can specify it here. This is for evaluating your existing hanger. So with this, we'd like to end the session. Okay. So what are the things we have observed in the session? So basically, we have come with the why we use the purpose of using the spring hanger in the piping system. Then we have seen that what are the different what we say criteria for selecting the spring hanger. What are the different types of spring hanger that are available, the mathematics behind selecting the spring hanger. So we have seen in Caesar 2 as well, and also we have seen these details in the uh, manual calculation, and we what we say check those reports, cross verify it, and it is exactly matching with my Caesar 2 report. Then we have seen what are the different settings options that are available in spring hanger design. Okay, so all these things we have seen here. So if you have any queries, or if you want to know more about it, or if you want to suggest some specific topic basically which we can do in future, okay, so you think that will be helpful for you, so that also you can. Hmm. And also we'll be taking some of the questions, okay, from here. So a question from Mr. Ramesh question that can you touch down when you have two different temperatures, as it is working like example 10 degrees centigrade and 170 degrees centigrade, how to set the spring control? So in that, okay, if you have the two different temperature range, okay, so definitely we need to check that in 170 degrees centigrade, okay, if it is the higher temperature, so definitely we have to first check in the operating condition whether it is lifting off or not. Okay, so once it is lifting off on that particular condition, so then only we can select that particular spring hanger. Similarly, for the lower temperature as well, we have to go, we have to see that whether it is off the support or not. Okay, if it is, then we have to follow the methodology what we have discussed. Okay. Now, another question that is, what is the importance of spring hanger in petroleum refinery industry? It's a very good question, basically. So, see, in the petroleum industry, we are very much interested on the safety purpose, right? So, considering the safety purpose, definitely the spring hanger selection is very much important, because, as I said, we cannot go for the under design of that. Okay, and also not over design also, because cost is also a factor. So that's why, as the name of our session also implies, to optimize the design. Okay, so that is very much important in that. In the petroleum industry, we have a lot of critical lines are there, high temperature lines are there. Okay, so for that, the lifting off is a very common phenomena. Definitely, we have to use this spring hangers for. Another question is, how spring hanger simulation in physics software is helpful in the real-time application? So in the real-time application, definitely, as I said, that we have done this with the manual calculation report, okay, and we have different load cases associated with it, and we also have seen these things in the 3D plot or in the graphical view also, okay. So we have seen it in the practical approach that when we have to use the spring hanger and how Caesar 2 is simulating that. Okay, and that also we have cross verified with the manual calculation. Another question from Ms. Shruti, what is the displacement criteria? Will this criteria is taken into consideration while selecting the constant or variable string? Okay. It's a very good question, Shruti. So I would like to answer this that the displacement criteria is nothing but if the piping system is moving, okay, that means the displacement is very much on the higher side. Okay, so in that case, we definitely have to go for the constant string angle. As per the EIL guideline, we have the 50 mm of the what we say movement we can accommodate. Okay, and if the movement is very much on the higher side, then definitely we can go for the constant angle. So we have certain practice for that. We have certain guidelines from EIL as well. Okay, so you can follow that guidelines and you can put that value in the input. Okay, so that the variability is another one, first one, and the second one is the displacement criteria. So if any one is met, Caesar 2 will directly go for the constant hanger spring instead of variable hanger spring. Yeah, this is the calculation for variability in the selecting the string. The variability part, sir, is nothing but your cold load minus your hot load divided by hot load. So that is the formula which we are using basically. So let me share my screen once again, the details once again. So here is the thing, with the variability, we have two formulas. The general formula is hot load minus cold load divided by your hot load. Okay. And another is if we go for the movement, means whatever the piping system is traveling multiplied by your screw rate, okay, divided by the hot load. So either of this formula we can use. Yeah, someone has requested for some topic related to jacketed piping. Yes, definitely we'll look into it and we'll try to do another session on jacketed piping. Yeah. So another thing is that coming to the rigid displacement criteria. So this is also a very good option that is available in this Caesar 2. Let me go to the settings option here. Okay. So rigid displacement criteria is nothing but if the load variation and the movement is very small, but you have selected as a spring hanger. But the software will determine that in that very small amount of load, it is not within the range of that particular, let's say, hanger vendor. Okay. So in that case, it will go for a normal spring support for you, rigid spring support for you. Okay. It will not go for a spring hanger. So it will reduce our cost basically because until and unless we are simulating that, okay, so we are not going to know the exact details, but we can definitely go for the rigid displacement criteria for that. Okay, so you can mention the criteria, what will be the amount of displacement for that. If the displacement value is very less, okay, let's say I have given the displacement value as 2 mm and my displacement is below 2 mm, then it will go for a what we say rigid support for that, not going for a spring support. Another question from Mr. Slava is that are there different standards and criteria for selecting a spring in the offshore piping? So for the offshore piping is nothing. There is the formula will be the what we say the same. Okay, but the thing is your variability and the displacement criteria may vary into it. Okay, so that based on the criticality of the system we need to because we have to provide very much what we say flexible. We have to provide very flexibility to the system piping system so that the load range and the displacement should be within that limit in that. But the procedure will be same. Yeah, if you want to select a 5% load variation, yes, it is fine, but I think 5% is very much stringent in that. I have come across a very stringent case around 12% of the load variation, not below that. But if you select 5%, then obviously the same methodology, if it is below the 5%, the load variation means your hot load minus cold load divided by hot load. If it is less than 5%, then it will go for a constant hanger spring. But that will be very stringent. So you can specify the industry what you are using in this. Okay. So we can definitely look into it and discuss further. Okay, so spring hanger should be used in certain conditions, like whenever we have a lift off, okay, or the pipe is going in the downward direction due to the higher temperature, let's say, or other operating conditions. So in those cases, to taking the load of the piping system as well as to allow the movement. So these are two basic criteria for selecting the spring hanger. That is related to another question is how new material manufacturer role in maintaining the quality in piping system in power sector. Okay, so that is again something related to the material science, sir. So see, constantly the different bodies like ASME say what we say section 2 part D, we have the detailed material database, and we have other what we say country database are there. So they are constantly working on the part to what we say to check the criteria of the different allowables of the material. Okay, and once it is done, so those things are accommodated in the software because Hexagon is such a OEM who is very aggressive on the product development part, and same goes with the Caesar 2 as well. So definitely, once you have the update, so if there is any change in the material property, so that must be accommodated in the software. So another thing is constant spring hanger should be avoided unless inevitable. Yes, Anirban sir, you're absolutely right. As and when required, if it is very, because we know that constant hanger spring is very expensive in that. So we need to put the engineering practice into it, and we need to definitely provide the different criteria for that. And it is such that in most of the cases, it will be the variable spring hanger only, but where the safety is utmost important for us. So in those cases, we have to go for the constant spring hanger. Okay. Another question is what failures in piping system can be eliminated using the spring hanger. So another thing is if let's say the one support is not there, we are eliminating one support from a particular condition. So the amount of load that is coming to the other support that is on the higher side, and such a condition may also arise the stress at a particular point because Caesar 2 works on as per the beam theory. So stress on a particular point will be on the higher side, and that should be greater than your allowable stress. So in that case also it may fail. Okay. So another important what we say question that is from Anirban sir, that is the allow short range spring. So short range spring is nothing but whenever we have the hanger catalog in that. Okay, so we have the load range defined. So we have the at the top we have the short one. We have at the bottom we have the middle range, and at the bottom we have the extended range of what we say loads. So if my criteria is within the short range, means at the top of the what we say part of any uh, you can say the size of the spring, if it is fits within that particular limit, then we can go for the short range spring. So it will for the most effective design to optimize this thing, but this should always not be happen. Okay, because we have other criteria also filled in the software. So based on that, Caesar 2 will do the optimization accordingly. Yes. And Anirban sir rightly said that short range springs are most effective and most economic. Yes.
The vendor document is being
In that case, sir, we definitely, yeah. Another question is, can we accept the vendor document if if the spring hanger spring rate not matching with the Caesar 2 output? In that case, definitely you can cross verify it, and you can definitely request for the manual calculation what the vendor has done. Okay, so that we can verify it with the Caesar 2 output. Another question is from Mr. Shawaz that many companies nowadays limiting the use of spring support and going for the conventional support changes. Uh, what can be the reason behind that? See, spring support in such a case, it is what we say, we must have to go for the spring support. Okay. And the conventional support changes is nothing but, see, spring support are mostly on the costlier side. So maybe sometimes to maintain the cost and to come within that limit, we may have to go for the what we say some other type of arrangements. Okay, the other rigid supports. Okay, so that's why in Caesar 2, what we say input criteria also it has been given that what will be the uh, selection criteria about the rigid support displacement criteria. Here you can see. So if the criteria fulfilled, then it will go for a rigid support instead of the spring support.
after running long time with the pipeline. The initial stage of hot load and cold load have been deviated from the original setting to variable spring support. Can we again reset the spring support to the original setting? If yes, then how?
Okay. So so another question from Mr. Pradeep. After running the a long time with a pipeline, the initial setting of hot load and cold load have been deviated from the original settings of a variable spring support. Okay. Now, see, in this reset condition is nothing but whenever you have some changes, if you are saying that for a brownfield project, if you change something on the support part, so that also you can provide the details in the Caesar 2 software and then again run that particular thing so that we can evaluate that particular spring hanger is accommodating that load or not. Means that's why the last three option now, the spring rate, the theoretically cold load, and the constant effort support load is there in the software. Yeah. Next question.
In case of variable load hangers are used in series of parallel at a suspension point, can you simply simulate it in Caesar 2 by using calculated spring stiffness, or there is any other way to do it?
No, the same with the spring stiffness only we have to do it. The same methodology what we follow. With that same thing, we can actually provide it. Yes.
Another question is why elasticity of spring is not considered in your calculation?
calculation.
See, in the spring hanger, the important criteria is the spring rate. So spring rate is definitely there. So in this output, we have seen that we have Caesar 2 is calculating the spring rate, okay, which we have also cross-verified with the manual calculation. That is nothing but 165 Newton per centimeter for this particular thing. So that is the what we say we are basically required for this calculation.
Next question is, if number of spring supports in a bigger plant need to be optimized, then what should be taken care of?
So in that, definitely the spring hanger vendor will definitely provide you some guidelines for the maintenance. So that we need to definitely adhere with that. Caesar 2 will not do much help about it. Okay, so because at the initial stage, it will help you to design that, but for maintaining that, we have to adhere with the support vendor requirement.
Another question is, why elasticity of spring is not considered in your calculation? It is done. Okay.
Yeah, it is done.
And another question is, above what size we go for multiple hanger at same node?
So in that case, you can say if it is more than 10 inch. Okay, and with the other configurations also. So mostly above 10 inch, we will consider the multiple spring at a particular point.
That's all.
Okay, so thank you all for your participation. And if you have any further queries or doubts, just do reach us. Okay, so we'll be glad to assist you. And also suggest some of the topics also which we can do again with the collaboration of IEI. And we'll be happy to do this kind of sessions in future as well. And also, if you would like to do such session, not only on the CZ2 or on the piping theory, if you want to specify some sessions on PV light or pressure vessel heat exchanger analysis, okay, so that also you can specify. Or if you are interested something on the what we say plan design, the 3D modeling part also, so that also you can suggest. So we can do such sessions also in future. So these are our contact details. Okay, so if you have any queries or if you have any specific requirement, just let us know. Okay, so and also you can visit our website at www.imagegrafix.com for further details, and there you will see what are the other solutions we are offering. Okay, and what are the other services also there. Okay, so definitely you can visit our website for that. So once again, thank you all for your participation and hope to see you soon in our future session. Thank you.
So with that, we
Have a nice
come
day.
to our today's end of our today's session. We are thankful to our speakers today, the esteemed speaker, Mr. Srinivas Kapati, Mr. Vishwarup Chatterjee, and also Kaustav Roy Choudhury. And this is a very interesting session. I thank all the participants also for participating in today's program. We are looking forward for more such interactive program and interesting program through this platform. Also, participants, those who want to have their certificate of participations can log in to our website. The link is given in the flyer in your mail which you receive. It will be open till tomorrow. After that, you cannot opt for your participation certificate. Once again, I thank you all of you. And this is we come to the end of this interesting session. Thank you.
Thank you. Thank you, sir.
Thank you, sir.